All right, guys, let's do it. This is question 1 from homework 11. It's a nasty little Cornell problem where there's 3 firms, but they all have different costs, and we have to find the Nash equilibrium. And we're going to be basically interested in, do the cheaper firms produce more or less than the higher cost firms? So let's start by writing firm 1's profit function. All right, so their price is 20 minus Q, but instead of Q, we're going to write Q1 plus Q2 plus Q3, because the capital Q is equal to the sum of the individual supply decisions of each firm minus their cost of 2 times Q1. And if we were to take the derivative with respect to their choice variable, we're going to have a negative 1 times Q1 here, plus 20 minus, if we distribute this negative sign, Q1 minus Q2 minus Q3 minus 2 is equal to 0. Okay. If we were to do the same thing for firm 2, everything would be the same except we would change this to a 2, and we would change this to C2, which is 4, and that would give us negative Q2 plus 20 minus Q1 minus Q2 minus Q3 minus 4 equals 0. And if we were going to do this for firm 3, everything would be the same except this would be a 3, and this would be a 6. So the derivative would be negative Q3 plus 20 minus Q1 minus Q2 minus Q3 minus 6 equals 0. So let's put everything a little bit cleaner over on this side. So 20 minus 2 is 18. And we've got minus Q1, Q2, Q3, but we have 2 Q1s. And that's equal to 0. This one, 20 is minus 4, so it's the same except it's 16 instead of, and we don't have 2 Q1s, we have 2 Q2s. And then the other one, we're subtracting 6, so it's 14 minus Q1 minus Q2 minus 2 Q3 is equal to 0. What we have here is a system of 3 equations and 3 unknowns. We could find the best response functions, but really what we need is a set of Q's that satisfies these 3 equations, because these embed the optimal decision rule in them. Okay, we just rearrange them to express them as the best response function. So we could do that if it's convenient, but we don't necessarily have to do that. Okay, cool. So there's a couple different ways you could go. One is that you might want to eliminate Q1 from 2 of these equations. So one way that you could do that is if we combine these last 2 equations but multiply the first one or the last one by negative 1 on both sides, then we basically have 16 minus 14, that's 2, negative 1 minus minus 1 or plus 1, that's 0. Negative 2 Q2 plus Q2 is minus Q2. And then minus Q3 plus 2 Q3, that's plus Q3 equals 0. And that's not such a nasty equation to work with. If we want to do the same trick using the first equation, because we're going to need 2 equations and we're going to have to bring in this first one, the information there, if we can't just combine, we have to basically somehow get these 2 to match, so we've got to multiply this bottom one by, say, negative 2 instead of negative 1. But that's still otherwise manageable. So 18 minus 28 is negative 10. Negative 2 Q1 plus 2 Q1 is 0. So we've eliminated the Q1 terms. Negative Q2 plus 2 Q2 is plus Q2. And negative Q3 plus 4 Q3 is plus 3 Q3. Okay? So these aren't as hard to solve. This bottom one, for example, can be nicely written as just Q2 is equal to Q3 plus 2. All right? So let's plug that into the first equation, and we're going to get, let's see, negative 10 plus Q3 plus 2 plus 3q3 equals 0. Okay, so this is negative 8 plus 4q3 equals 0. And that tells us that q3 equals 2, because 2 times 8 plus negative 8 is equal to 0. Now we go straight to over here. q2 is equal to q3 plus 2. So we know that q2 is equal to 4. Easy. q1 is a little bit harder. We have to plug it back into one of these equations. 18 minus 2q1 minus 2 minus 4 equals 0. So 18 minus 2 minus 4 is 18 minus 6. So that's 12 minus 2q1 equals 0. That tells us that q1 is equal to 6. Seems really easy, but let me tell you, this is the third time I've tried to solve this problem for you guys, okay? And I have the answer key. It's not actually hard, it's just there's a lot of things to keep track of, and if you make a mistake somewhere along the way, you know, it's very hard to undo. So you just have to be very careful, but it's not actually, it's still just basic algebra that you've known for years. All right, but let's see if this makes sense. So the most expensive firm has marginal cost of 6. The second most has, so the most expensive firm has marginal cost of 6, and he also produces the least, just 2 units. The cheapest firm has marginal cost 2, and he's producing more. So this is a Nash equilibrium where the most efficient firms do indeed produce more than higher cost firms. All right. So using those solutions, compute the industry output, the market equilibrium price, and market shares. I guess that was supposed to be, they're supposed to have a little more space for that, but that's okay. We got all this room up here. So as a refresher, we've got Q1 equals 6, Q2 equals 4, and Q3 equals 2, which means capital Q is equal to 12 if we add those 3 numbers together, and the price is equal to 20 minus 12, or 8. Okay, so what are their shares? S1 is 6 over 12, which is 1/2. So half the market is supplied by firm 1. S2 is equal to 4 over 12, which is equal to 1/3. And S3 is equal to 2 over 12, 1/6. All right, so this is the shares of the market, and we can see the most efficient firm has a bigger share than anybody else. Using your results, compute the Lerner index and the Herfindahl index H. Okay, so let's do the Lerner index first. The industry-wide Lerner index is equal to the sum over firms 1 to 3 of their share of the market times their individual Lerner index. They all have the same price, but they have different costs, and so they're going to end up having different markups. So firm 1 has 1/2 of the market. They all charge a price of 8. He's got a cost of 2. Firm 2 has 1/3 of the market. Same price of 8, but a cost of 4. And firm 3 has 1/6 of the market. And cost is 6. So we have to basically do this math now. So this is 1/2 times 6/8, or 1/2 times 3/4, plus 1/3 times 1/2, plus 1/6 times 1/4. And pause while I get a calculator. I get 0.583 repeating here. The Herfindahl index, as a reminder, is the sum of each person's share of the market squared. So that's equal to 1/2 squared plus 1/3 squared plus 1/6 squared, or 1/4 plus 1/9 plus 1/36, which is equal to 0.38 repeating. All right, so now to check that these numbers are correct, we got to find the elasticity and see if our learner index satisfies the elasticity rule. Okay, so if our firms are profit maximizing, we should get this equation L is equal to H over negative elasticity. So if that's the case, what does that imply that this should be equal to? It should say that the elasticity is equal to negative H over L. Our H is 0.38 repeating. Our L is 0.583 repeating, I believe. Let's see. Yep. So what's this imply? Our elasticity will be 0.6 repeating, basically 2/3. So is that right? Well, we can check by using our demand equation here. So the elasticity of demand was Q equals 20 minus P, or we originally had the inverse demand, 20 minus Q. So if we take the derivative of this, multiply by P over Q, we get the elasticity. And so the derivative of this guy is -1. Our price is 8. Our quantity is 12. And what do you know? That's -2/3, or -0.6 repeating, which is what we got up here, at least until I forgot to write the negative sign. Okay, so it worked. What's the point? We kind of showed that these concentration measures do tell us, who's got the biggest markup. But what's kind of interesting here is, in this case, the firm with the biggest markup the reason they had a big share is because they're the most efficient. And that's actually the guy that we would sort of want doing all this stuff, right? If we got him out of the picture, we could lower the learner index, or if we changed his cost to one of the other guys, maybe we could, we could maybe improve how things look on the learner index, but the actual cost would go up. So this sort of illustrates that it's not always so clear cut what we're trying to achieve. It's not inherently bad for a firm to make a profit. You would want the most efficient firm to basically, provide the most good, produce the most. That's the most efficient use of resources.